Today's lesson is on scientific notation. We're going to be reading scientific notation and then telling whether they are in scientific notation and then also writing a number in what's called standard form. So scientific notation is a number represented as the product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. That's the key piece to writing in scientific notation. So when you look at these first two, you want to see if they are in scientific notation or not. So in letter A, you say, okay, well, the factor, is it greater than or equal to 1, but still less than 10? And in this one, yes, this is your factor. It is. It's at 5.9, so that's right in between 1 and 10. And then it has to be multiplied by a power of 10, which this one is. So yes, this one is written in scientific notation. And then the reasoning behind it is because this is in between 1 and 10. So then if you look at B, no, this isn't. This is not scientific notation since it is 9/10, which is not a number that's in between 1 and 10. So if we want to take a number in scientific notation and then write it in what's called standard form, which is the normal way you see most numbers, there's just two rules here. So move your decimal point the number of places that matches the absolute value of the exponent. If the exponent is negative, move the decimal place to the left. If the exponent is positive, move the decimal place to the right. So, and then fill in any empty spaces with zeros. So looking at number 1, you see that you have 3.22 times 10 to the negative 4th. It would make sense that we need to make, since it's 10 to the negative 4th, which is 1 over 10 to the 4th, we need to make this number smaller. That's why we're going to take our decimal place and just simply move it 4 places to the left. So 1, 2, 3, 4. And then you're going to fill in any space you have with zeros. So 0. You got 1, 2, 3. 3 zeros, and then 3, 2, 2. This is now in what's called standard form. When you have a value that has 10 to a positive power, you move your decimal place to the right, because think about this, you're multiplying this by 10 to the 5th, which is the one with the 5 zeros. So you're simply taking 7.9 and going 1, 2, 3, 4, 5. Any holes you're going to fill in with zeros. So you have 790,000. So pause the video. I want you to do 3, 4, 5, and 6, and then unpause, and you will see the answers. Okay, so for number 3, you'll see that even if there is no decimal shown in the number, there is a decimal always at the end of a whole number. So right there is your decimal point. So you're going to move it 5 places to the left. Number 4, you're moving 7 places to the right. 5, you are moving 9 places to the left, so you should have 8 zeros in front of that number. And then in number 6, it's 12,850. It just dawned on me as I pulled this down that there were 3 problems from yesterday's lesson that we didn't do. So actually, I'm going to kind of take a moment here. I'm going to stop scientific notation. I'm going to back up to these 3 different problems, and I want you to take a look at them. I want you to try them. They are very similar to the ones that we did yesterday, and just see if you can get them on your own. So right now, what I want you to do is pause that video and try 7, 8, and 9. Hopefully you took a few minutes to try those out. So number 7 is 8 over x squared, because the x squared jumps to the denominator, because it's 1 over x squared. Number 8, you are adding 0 and negative 10, so you're going to get b to the negative 10th, which simplifies into 1 over b to the 10th. And then in number 9, you have a 15 in your denominator, and then you have 6, or x to the 6 minus the 9. So that's in your numerator, you'll have x to the negative 3rd, which then jumps that actually to the denominator. So there's those 3. Back to scientific notation. Yay! The last piece that we have here is comparing numbers in scientific notation. So there's 2 different ways that you can do these. You can either write them in standard form and compare them, or you can use the same power of 10 and compare your factors. So what I want you to do is pause the video, and I want you to choose which way you want to do it. Either write them in standard form, so convert all of them to standard form, or figure out how to make them have the same power of 10 by manipulating your factor, and then compare the factors. That's going to be a vital piece when we actually add and subtract, and multiply and divide in scientific notation. So pause the video and decide which way you want to do, and then unpause and the answer will be up there. So here's the two different ways. In where I have listed as number 1, that's when I took the number and made it into standard form. What I have as number 2 is when I took the number and created a common power of 10. So these first two have the same power of 10, but this third one I had to adjust. So if I took away a power of 10 from here and had to give it to here, so I simply moved my decimal left one place here and then upped this one place. So the next piece says, explain what happens when you place a brick and an apple in water. Well, since water is at 1,000 kilograms per cubic meter, the brick is denser and it'll sink, but the apple is less dense, so it'll float.